Science Olympiad, Class 7. Light.
Introduction. Light is a form of energy. It travels at a very high speed. We are able to see things only because light from them enters our eyes. Have you ever been frightened by your own shadow? Shadows occur due to the fact that light travels in a straight line. This property is called rectilinear propagation of light. Light exhibits typical phenomenon of wave motion such as reflection, refraction, and formation of images. Rectilinear propagation of light. Light travels in a straight line. This is called the rectilinear propagation of light. While seeing a film in a cinema hall, you may have noticed that the light from the projector appears to go in a straight line towards the screen. In a cinema hall, what you see is not light itself, but innumerable dust particles in the path of light, which become visible when light falls on them. The above example shows that light travels in straight lines. This phenomenon is called the rectilinear propagation of light.
General definitions related to light. Luminous bodies. An object that emits its own light is called a luminous body. Example: sun, stars, glowworm, a burning candle, and electrolytes. Non-luminous objects. An object that does not give out its light but becomes visible when light from a luminous object falls on it is called non-luminous object. Example: moon, earth, book, and table, etc. Optical medium. The term medium is used for any substance through which light might pass. Example: glass, water, air, etc. Transparent medium. Substances that allow most of the light to pass through them are called transparent substances. We can see through them clearly. A transparent substance is called an optical medium. Glass, water, air, etc. Translucent medium. Substances which allows only a part of the light to pass through it and through which object cannot be distinctly seen. Example: butter paper, paraffin wax, greased paper, ground glass, etc. Opaque medium. Opaque medium is one that does not allow any light to pass through it. They reflect or absorb all the light that falls on them. We cannot see through them. Example: wood, stone, rubber, walls, books, etc. Homogeneous medium. An optical medium which has uniform composition throughout is called homogeneous medium. Example: glass, diamond, distilled water, a sheet of clear plastic, vacuum, pure alcohol, etc. Heterogeneous medium. An optical medium which has different compositions at different points is called heterogeneous medium. Example: air, muddy water, fog, mist, smoke or clouds, etc. Point source of light. If a screen with a pinhole is placed in front of a lighted bulb, then a point source of light is obtained. From the point source, light propagates uniformly in all directions. A ray. Light from a point source spreads out in all directions. The directions of very narrow path of light is known as a ray of light. A ray of light is represented by a straight line with an arrowhead. The arrowhead on it gives the direction of light. Beam of light. A collection of rays of light is called a beam of light. A beam of light is classified into three kinds, namely parallel beam of light, convergent beam of light, divergent beam of light. Parallel beam of light. These rays of light are parallel to each other such that the distance between the rays remains the same. Light from distant objects give a parallel beam of light. Convergent beam of light. In a convergent beam of light, the light rays meet at a point. Divergent beam of light. In a divergent beam of light, the light rays spread out from a point. Reflection. The phenomenon by virtue of which incident light energy is partly or completely sent back into the same medium from which it is coming after being obstructed by a surface is called reflection.
Laws of refraction. The incident ray, the refracted ray, and the normal at the point of incidence lie on the same plane. For a given pair of media and for a particular color of light, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. That is, sin I by sin R is equal to constant. The second law is also called Snell's law. Kaleidoscope. The principle of multiple images by reflection from inclined mirrors is used in a kaleidoscope. The kaleidoscope consists of a cardboard tube fitted with three long narrow plane mirrors M1, M2, inclined at an angle of 60 degrees to one another. One end of the tube is closed with two circular glass plates, the outer one being made of ground glass and the inner one of transparent glass. A few pieces of colored glass are kept between the two glass plates. The other end of the tube is closed with a disc which has a hole in the center through which the glass pieces can be viewed. When the tube is held against a bright background, a colorful design can be seen. Each pair of the mirrors forms 5 images, which, along with the object, form a hexagonal pattern. Since there are 3 pairs of mirrors, 3 sets of hexagonal patterns are seen. When the tube is rotated slowly, new patterns are formed. Braille System. The most popular resources for visually challenged persons is Braille. Braille System has 63 dot patterns or characters. Each character represents a letter, a combination of letters, a common word, or a grammatical sign. Dots are arranged in cells of 2 vertical rows of 3 dots each. Patterns of dots to represent some English alphabets and some common words are shown below. These patterns, when embossed on Braille sheets, help visually challenged persons to recognize words by touching them. To make them easier to touch, the dots are raised slightly. Visually challenged people learn the Braille system by beginning with letters, then special characters, and letters combinations. Methods depend upon recognition by touching. Each character has to be memorized. Braille texts can be produced by hand or by a machine. Typewriter-like devices and printing machines have now been developed. Regular reflection. Regular reflection occurs when a beam of light falls on a smooth and polished surface. Example, plane mirror. If a parallel beam of light falls on a plane mirror, the reflected beam is also parallel and is in a fixed direction. Irregular reflection. It takes place when the reflecting surface is not smooth or polished. For example, wall, wood, paper, and metal. In this case, the different parts of the surface reflect the incident light in different directions. If a parallel beam of light is incident on a rough surface, the reflected light spreads over a wide range of area. Such a reflection is called diffused or irregular reflection. It is the diffused light which enables us to see through such objects around us. Mirror. Any smooth polished surface which can return the ray of light into the same medium is called a mirror. Looking glass is the best example of a mirror. Any highly polished metal surface also acts as a mirror. Still water or oil have a smooth surface and hence act like a mirror. Even highly polished furniture act like mirrors. Spherical mirrors. There are two types of spherical mirrors, one concave mirrors and two convex mirrors as shown in the figure. In a concave mirror, its outer surface is polished, and in the case of a convex mirror, its inner surface is polished. Usually, a spherical mirror is represented by drawing its section. Pole. The central point of a mirror is called its pole. Center of curvature. The center of the sphere of which the mirror is a part is called the center of curvature of the mirror. Focus. If rays of light parallel to the principal axis are incident on a concave mirror, they converge to a point F on the principal axis after reflection from the mirror. This point is called focus of the concave mirror. Focal length. The distance FP between the center of curvature C of the mirror and its pole P is called the focal length of the mirror. If a point source of light is placed at the focus of a concave mirror, the rays of light starting from focus after reflection from the mirror are rendered parallel to the principal axis, as shown in figure. Reflection in a plane mirror. A mirror having a plane surface is called a plane mirror. When light falls on a plane mirror, regular reflection takes place. The ray AO that falls on the mirror is called the incident ray. The ray OB that is thrown back into the same medium by the reflecting surface is called the reflected ray. The point O on the mirror where the incident ray strikes the mirror is called the point of incidence. The ray perpendicular to the mirror at the point of incidence is called the normal at the point of incidence. The angle between the incident ray and the normal is the angle of incidence, I, and the angle between the reflected ray and the normal is the angle of reflection, R. Formation of images with convex mirror. Convex mirrors always produce virtual images of the objects placed in front of them. The images produced are erect but smaller in size and formed behind the mirror. Figure shows the formation of the image of an object. Because of this property of convex mirrors, drivers of cars, trucks and buses, etc. use convex mirrors to get a wide view of the whole traffic coming from behind. Uses of concave and convex mirrors. Concave mirrors are used as shaving mirrors, as reflectors in torches, search headlights, etc. in reflecting telescopes. Convex mirrors. Convex mirrors are used as rear-view mirrors in vehicles because they have a wide field of vision.